1, go. 30.
In this series, we're showing how to get and use the telemetry data from Dirt Rally 2. This video is about getting the data in C# code and displaying it in its raw values like this. I will upload all the code to GitHub, so have a look in the description below to see its link. Let's create a new C# Windows Forms project. We'll add a button and change its text and name to connect, and then we'll double click it to go to the code for it. Here is a simplified version of the code. On this line we use the systemnet sockets to make a UDP client, and we set its exclusive address to false so we don't lock the port number it's listening to. We then make an IP address using the IP address from the config file and set a variable to hold the port number that was defined in the config file as well. We then make an endpoint from them two variables and tell the UDP game data to bind and listen to that endpoint. Next, we call the receive method of the game data, and this is the bit that has a problem at the moment. Currently, it will lock the UI thread and wait here until the game sends a message before it continues down below. This is not what we want to happen. We would rather the app stays responsive and just informs us when a new message comes in. The last bit of code just closes and disposes the game data connection when we are done listening for messages. A good way to fix the UI lock is to use asynchronous programming. So let's make the method async, and we'll update the listen to have a method that is async as well. We now await the new listen method. This allows the main UI thread to continue running smoothly while the listen method handles its own work separately. I have added the new async listen method. It has a loop. We do this because we don't just want one message, we want to continue getting data from the game while the listen method is running. The loop code will wait at the receive async method, and once the game sends a bit of data, we'll read its buffer to pull out the bytes that it has. It will then loop around and wait for the next bit of data to come from the game. There is one more thing we need to do. Currently the listen method is in a never-ending loop as we're looping while true. So we need a way to exit if we want to stop listening for the game data. The way to stop the listen method is with cooperative cancellation. We declare a token source at the class level. Before we start the listen loop, we make a new cancellation token source and then pass its token into the listen method. In the listen method, at the most reactive spot just after it receives a message, we check the cancellation token to see if a cancellation was requested, and if so, we return from the loop exiting out of the listen method. Now all we need is a way to cancel it. To do this, we'll add a new disconnect button, set its text and its name. In the disconnect, we check if the cancellation token source has been created, and if so, cancel it, and at that point we can dispose it. I will tidy the code up a bit now. I'll disable the disconnect button in the form designer and enable it in the connect method, as well as disabling the connect button so that you can't connect twice. I have moved the disconnect code to its own method and call it from the disconnect button as well as from the form closing event. Then in the disconnect, I'll enable the connect button again and disable the disconnect button. This will ensure it's always disconnected no matter how we end the app. It's time to give it a test to see if it's working. Make sure your Dirt Rally 2 config file is set up correctly to send out its game data. I explained how to do this in a previous video if you missed it. Let's put a breakpoint right after the receive async so we can see if we're getting some data. Run the app and then press the connect button. I have Dirt Rally 2 running in Windows mode so I can test this easier. So when we start a game, we should see the data come through. there it is. If you hover over the buffer, you can see it's a byte array. This is all the bytes of the game's data. We'll now have a look at turning that into something more readable that we can actually use. I have added a new class with a struct to hold the Dirt Rally 2 telemetry data. It is used to convert the byte array into name properties with the correct offsets and field types. Once it's in this format, the data makes a lot more sense. I have another video that explains each of these properties in lots of detail, the complete missing telemetry guide, so make sure you check it out. I have also commented out the properties that don't make much sense in this instance. They're always 0 for Dirt Rally 2. This happened because they're inherited from the F1 game structure that Dirt Rally 2 is just reusing. Let's update the code to use the new structure. I've added this method. It is a good way to convert a byte array to a structure when the structure has all the correct offsets to match the byte array we are converting from. Once we have it, we can use it like this. So we pass in the data array and it will convert it and give us a structure. This structure has all the properties from the Dirt Rally 2 game in a clear, readable way. Now would be a good time to display the data. I've added a bunch of labels to my form to show all the values, and I've added a method to set them from the telemetry structure into the labels. After we get the data, I will call the new update method. There is a few things we need to be careful of when calling this method. Firstly, it receives a lot of messages very quickly. The config file controls the rate at which the messages are sent, with the default 1 meaning 1,000 messages a second. It doesn't actually come that quickly though. It's based on frame rate, UDP bandwidth constraints, and internal rate limiting added by codemasters to prevent flooding the network or overwhelming telemetry tools. Realistically, we get about 10 to maybe 20 messages a second. You could set this to 1,000 if you wanted to, for example, limit it to 1 a second. The first thing we'll do is use a currently updating boolean. We check that this is false before the update, then set it to true, do our update, and set it back to false when we're finished. So it only updates when we have finished all the code in our last update. Secondly, when the messages are received, they come from the UDP socket thread. We need to call the code on our UI thread or we'll get cross-threaded exceptions. Using an invoke, we can get back to the UI thread to do our update. Now let's see it in action. I'll connect, start the game.
5, 4, 3, 2, 1.
Cool, the Dirt Rally 2 telemetry is coming through perfectly. Don't forget to check out our other video, the complete missing telemetry guide, to help make sense of all these numbers. Subscribe to see our future videos where I'll turn these numbers into gauges, maps, scoreboards and other awesome things.